going through the recording again. Is the recording helpful?
Yeah, I went through the recording when I was doing my assignment. It was really
Okay.
Even I went.
Okay, so I'll record every class and I'll post it so that, in case I started recording right now. So basically, quick thing about lists is, so there are again a lot of functions in a list, like you can get the length of the list. But main thing is this function. How do you append a list? By saying dot append. So this is what we have. I'm hoping you guys have used it in the project which we created. So lists. So takeaway from lists is a replacement for arrays in Python. If you explicitly want to use array functions, we use this package called NumPy, where it has a lot of other functionalities of arrays and matrices and stuff. Then we went ahead. So this is one data structure which we use. Generally, we use lists to store a bunch of each individual objects. So we can create a list of strings, we can create a list of dictionaries, we can create a list of, so whenever you want to store a bunch of them, like, if you have multiple things of the same type, you use a list to store them. But if you want to have information about one object, the best data structure to use is dictionaries. Use of dictionary is what we have seen. Like, for example, if you have, you can kind of think of it like a class, but it is not a class replacement as such, because dictionary is again a data type object. It's not a class. But then for a quick way to actually store everything into one object, we actually use dictionaries. One main example of dictionary is like the thing which we have done. Like when you have one employee of a company and you want to store his information, like his name, age, qualification, salary. So in general, even in C# and stuff, we have dictionaries, but then they generally go with classes, and we can do classes in Python also. It's object oriented, but we are not going into all that because we don't need that level of reference. We just need to know how to call Python functions and create data structures to store for our programs. So dictionary again is used for storing information. It has key value pairs. The way we initialize it is by saying the key and the value. Just note the syntax. For dictionary, we will actually use curly braces, and then every field is separated by comma. So like name, so key colon value, and then comma key colon value. And how do we access a particular value in the dictionary is by saying dictionary awks, similar to like how we do. So only thing is, instead of the index here, we will use the key name. So this is how we access even in lists. But then in lists, we use the index because index actually points to that particular value. In case of a dictionary, we use the key name. So we will use the key name of it, and it will give you the output of whatever the value of that is. So that is a dictionary. But key takeaway from this is we use it for storing key value pairs of certain object. So now combining both dictionaries and lists, we can actually store the information of 10 employees or 15 employees in one list, where each element in the list is a dictionary. Is that clear?
Yes, sir.
Okay, cool. I think these are pretty simple, like condition statements, where like it's the same as while and for conditions. Only thing is the syntax is slightly different. For for loops, we don't have for int I equals 1 to like I equal this thing. We'll just say for I in a certain range, or for I in a certain iterator. Again, for this thing, we use and or operations. Like we just have, because remember the first thing I said was Python is a language which is very readable. So they try to use as many English words as possible. So they don't use like ampersands or this thing. So you have to use and or. So that was a quick thing on statements. Again, break, continue, and pass. Break is when you want to break out of a particular iteration. Like if you're running for I in range 1 to 10, if you want to break out after 5, you use break. You want to use continue before when you don't want to execute anything after continue, but continue with the loop. Pass statement generally is a no-op sort of an operation in Python. It is mainly used for when people want to put like some kind of like in the future, if they want to like let's say for a particular case, like when I equals 0, they just say pass. So it just, and it'll still continue whatever is there next, but that pass is a reminder for them that in the future they need to come and like uh, write the code again. Exception handling, we talked about assertions and we talked about try and except, and finally. So assertions, again, we'd use them mainly for test purposes. It's very useful for programmers. So assertions, we generally, when the programmer guesses what the input is, like what the input should be. Like for example, if he's doing a division operation, he will assert that the whatever he's dividing by is not equal to 0 because he knows he'll get a divide by 0. So as a programmer, you use assertions to ensure that the other part of your code is not executed when the basic minimum conditions are not met. In general, we use it for debug cases and test cases. At least in production, assertions don't trigger. At least in Windows and stuff like that, they don't trigger. But you can. I've read somewhere that you can configure the release builds also to run assertions. So it's up to you guys. But exceptions are in general used when you don't anticipate what the exception, like what the user's input is. Like you have tried your level best to make assertions, but there might be a lot of cases where you don't anticipate certain thing happening. So the best way to protect from such kind of thing is by using try and except. Just note that in most languages it's catch, in Python it is except. So, and then the two ways to handle exceptions. One is catch a generic exception. The way you catch a generic exception is by saying except. Let us do exception. Generic exception you catch by saying except exception as E. This will catch all the exceptions. But when you want to actually catch a specific exception, you will say except index error. And like in this case, because you know it's an index error. So that's how you'll do. And then finally is always executed. So a best programming practice is basically whenever you use finally, you write the cleanup code here. So in general, like you clean up resources or you say delete, let's say you have created a big list here and your program is done, you will just delete that list. So finally is always executed, irrespective of except is called or not. So in case there is no exception, it will run the code in try and will go to finally. In case there's an exception, try will throw an exception, except will handle it, and then finally is called. So key note here is to remember that finally is always run. So that's one thing which we did. I'll give a quick review of functions. First thing, how do you, we use functions because whenever you want to reuse the code, we use it. And how do you define functions? By whenever you use the word def, that's how a function is defined. And then followed by parentheses. Parentheses can have whatever arguments you have. But then there are three main things of, and note that if you don't have the colon, so colon is a very important operator. If you've noticed, most Python programming, even in if and else conditions, like in loops, conditional loops, if you don't have colon, it won't run. So a lot of people miss this because in most of like Java, C# and stuff, we don't have this. Generally we say this and it'll start. So I think if you're running the code and writing the code yourself, you'll run into this issue of if you don't provide colon, it won't understand. So you see it's an error here. So similarly, colon is very important even for loops, and and even for functions. So even for functions, we need to, when you start, so define custom print input operation and then colon. And then how does it know what is in the function? It's by indentation. So if you give the right indentation, it will do it. Return is optional. If it doesn't have return types, you can omit it, but I generally write it so that you know that the function ends. So if it doesn't have any return types, you can totally omit it. But then it's a good programming practice to actually finish off this thing. But then the main things in functions are the following. There are 4 kinds of things which a function supports. One is optional arguments. Where do we use optional arguments? Let's look at functions. So optional arguments means that, I think I'll show you even the assignment example which we did. So in optional arguments, let's say if you're populating, let's say you're taking in, let me just go to that assignment. So in file handling, let's say if I'm adding an employee, right? If I'm adding an employee, Sorry, is there a question? Okay, I heard someone ask. I mean, you can feel free to stop me anytime, but I thought someone said something. Anyways, so basically, whenever you're adding an employee, right? I said, so how many of you finished the assignment or at least got a hang of it? I got 4 people who sent me their assignments. Like 2 others, I didn't get any assignments, but I'm hoping that you're following what I'm doing. If you have written the assignment, it's well and good. Because I want to add just one additional things to your assignment today. But I've sent this code, so feel free to like open and run it. So again, optional arguments are basically, let's say in this case, I'm adding an employee, right? And I'm taking the name, age, and ID. Sometimes when the user doesn't input a title, I by default assume it. I say it's an optional thing because by default I have a title of SDE for him. So if someone gives exclusively a title, it will take that title. If they don't give the title, it will by default take it as SDE. So that's optional arguments. But that is pretty much supported in every language. But the main thing is variable arguments. One place where we saw variable arguments is print. So when you do print, you can give 10 objects, 10 strings, 20 strings, 30 strings. Like if you come from other programming languages, you will be thinking that, oh, is there an implementation for print with 10, is this function signature for print having 10 strings, 20 strings? No, because it's highly impossible to write every combination. So the way Python handles that is by using a single star operation. So it's not an operation, by using a star character. So where is that? Here. So in this case, when I give one asterisk, actually not star, it's an asterisk. So when I use one asterisk and say this thing, that means that this function can take multiple arguments. But then once you have these arguments, you don't know what is inside the arguments, right? Because people can pass in like a ton of things. Like for example, in this case, and all of them need not be of the same type. You can pass different things. But then if I want to know what each individual one is, like if I want to, I can only print like arcs of 2 or arcs of 10 or arcs of this thing, but I won't know what each one of them is there. So they went one step further and then they made something called as keyword arguments. Keyword arguments means actually multiple arguments, variable arguments, the same thing. Keyword arguments means you are actually giving a name, a key to every argument you pass. So the way you call a function is by giving, like for example, you have John, actor, none 32. You give it a name. You give it a particular key. So it's like key value pairs. You can pass key value pairs to your function. But your function signature should have 2 asterisks to accept it. If it doesn't have 2 asterisks, it won't know that it's keyword arguments. So when you actually pass in like name equals John, occupation equals actor, age equals 32. Now this is what a keyword is. You have a key. It's similar to key value pair. So this is how you call, you call that function. But if you are defining that function, you will use 2 asterisks. The advantage of this is you can print in any order. Now I know, because you have a key, right? Similar to dictionary. Why is dictionary so useful? You put in all the fields, whatever field you want, you will access it like you're accessing it in an array element, right? So now I can actually say keyword arcs of occupation, it will print occupation. Keyword arcs of age, it will print age. It will do this thing. So you can combine exclusively if you want to, like, so you can combine 2 things also. Let's say if I actually say something like name, comma, this thing. So what it'll do is it'll take first this name and put it in name. And then the rest of them will be put in this keyword arguments. You can actually have an option to do both. But in general, if you're actually using keyword arguments, it's better to use everything. You will see a lot of times when you're looking at other Python code, you will see that this is there, which is very unusual as compared to other languages, because other languages don't support, like maybe okay, C# and Java, I don't think they support these. Maybe there are some languages which do, which I don't know. But then advantage of keyword arguments is when you have, like today we are going to see the Indian liver patients example. You have different features.
Sorry, quick question like this, Raghav. So how do I name this? I mean, is there an option where I can name the functions so that I can reuse them everywhere?
Name the function meaning?
Yeah, for
This is,
example.
so this is the name of your function, right?
Yeah. Okay. So keyword is the name.
Yeah. So I mean, I
It
can
could
make
be
this.
anything.
Yeah, this is anything. So this can be like my args. So
Okay.
this is so okay. So there are two things. This is how you write the function. Wherever you have def, that means you're defining the function.
Okay.
This is how you call it. Maybe I think yeah, that's a good thing, because first time when you're saying this is calling of the function. So this is how you use this. Now I made this my arg. So I'll call the function by giving these keywords, my args, and this is how you define the function. So you define the function. Yeah. So you can create any function name. Like you can create my args. You can create like you can give any function name of your choice, and then you can. This is how you define it, and this is how you call. Just 1 second. Okay, we don't
So
have Jatin.
yeah, all these functions, when I write it, I can store it in single Python file, right? Like imagine I'm
Yeah,
writing.
you can store it in single Python file. Just sorry, one quick thing. I think I did not send the email to Jatin, or maybe he's not there. Does anyone know Jatin, or just one second? Let me just see if I did send. I think I sent the email. Sorry, let me just. I think I did. Let me just quickly send it to him. All right. Sorry. Yeah, you can write any number of functions you want in your file. So you can create any number of functions, whichever you feel like creating. You can create, and this is how you call it. So when you're defining the function, you will actually use 2 carets, but when you are actually calling the function, you will use keyword arguments to do it.
Yeah.
Is that clear, Raghav? Any other question?
Yeah. Yeah. That's it for now. I think in the future we're going to learn how to use the function in a different program, right?
Yeah, we will use all that. So basically, but then if you want to create this thing, so that is that's the main thing about functions which we learned. 2 things. It's pass by value, pass by reference. In Python, we always pass by reference. What does that mean? Whenever you're sending some value, some object here, if you modify it in the function, it will get changed even outside the function. The reason being, it's taking a reference of that object. It's not creating a copy of it. So in pass by value, what happens is it creates a copy of it. So like you can do anything to the copy, but the original won't change. But when you're passing by reference, it's actually referring to the original object itself. So anything you change there will be affected. So that's pass by value and pass by reference. Let's do. Actually, this one is something I don't think I mentioned last time: global variables and local variables. So in global variables, what you can actually define like in, I think in case of your assignment, if you have done it, it will basically be, in case of your assignment, whenever you are actually creating here, in this case, what I did is I created a list, which is because I need to access this list in every function, right? When I want to print the list, I need to access it. When I want to add employees to this, so I made it a global variable. So when I make it a global variable, I actually define it outside. But anything which is defined in the function is basically a variable which is local to the function. There's one more thing. Like I did not give this in the assignment, but I wanted you to create an ID which is basically auto-generated. So That what that means is basically so the user will not input the ID. The user will only input the name, age, and their title. The ID should be generated automatically. If you see the mini project thing, I've used if you've seen this thing, I've used ID also as a global object. So I've used two things as a global objects. One is basically employee info, which is a list, and it's an empty list initially. And I made ID also as a global variable. The reason I did that was because I wanted to create, and maybe I'll do this Lambda function also now. I wanted to, so the way you access this ID, because I'm using this ID inside also, right? I have to exclusively use the word global. When I say global ID, that means the function will know that this particular ID is this global ID, and then so I'll cover what is Lambda function is in a bit. So that's pretty much local and global variables which we did.
Sai, one
Yes.
question.
Yeah.
So this ID thing, right? I did use this line in my code. ID value equals lambda ID colon ID plus 1. It was just giving me 0, 0 for everything for subsequent.
Because maybe you didn't use global.
Okay.
So ID equals 0. You need to get a reference of this particular thing.
Yeah.
Like if you, so now when I say global, it's saying that it is basically this particular global is basically this thing. Lambda functions, I don't think I covered last time because I didn't have time, but we'll just go through what Lambda functions are this time.
Okay.
But you understood what a global variable is, right? Global variable is anything defined outside.
Yeah.
And then we actually do it within this thing.
Yeah, I think I used global also. I'm not sure. I'll try it again.
Yeah, if not, we'll share. You can share the screen and then.
I just removed that line, lambda thing.
Yeah, because I did not cover what lambda. So we'll just quickly cover what lambda is. Lambda functions are. So yield keyword, everyone, I think I said that yield keyword is generally used when you're trying to access information from a big database and you don't want to wait for all the, for getting all the data, because one, that is the huge object. Second, you have to wait for all the object to be populated. So the yield keyword is used when you want to return, as soon as you get something, you return it. So a best example for that is, I've actually, this is not because our data is really small. So that's why I don't think you will understand the use of the word yield here. But let's imagine you have like 1 million employees in your, hypothetically, you have 1 million employees in your company, and all those employees are saved as a text. Like you are reading a text and you're reading from that file. And then I want the name. I want you to return me the list of all the employee names. Then what will you do? You'll actually go through every line and populate your list with the names, and then wait till all those 1 million things are done, and then you send it back. So this is two things. What if you're what if there is a memory overload and your program crashes then? So that is one thing. And secondly, you have to wait on this function like for a long time till it populates. So yield keyword, what it does is, as soon as it says for line in this file, yield the line. So as soon as it reads it, it'll send this to your function. So you can see that. But again, because you're getting one thing at a time, you should use that as a iterator only. Like, because you're getting one thing at a time, so you're saying employee in this thing, you're going to process the employee here. So the difference between return and yield is, once you use return, it'll return and it'll not come back to this function again. So yield is like a temporary return. So you say, I get this line, I send it here, and then I again get the next line, and then let them process this line. Next time when they come here, they'll wait for the next line, and then you can use. So this is the exact use of it is not seen here because the file is not that big. But if you have a really big file, you will see the use of you'll see the use of it. So everyone clear with what yield does? It's really useful when you're writing like code and especially in services and stuff. We did not do Lambda functions, but Lambda functions are quick functions. So the things with Lambda function is that you don't need a def keyword. You will say that when So in general, right, if you want to like multiply two things, or you want to double a value, so you have to write a function saying def double value take x colon, and then x equals x into this thing, and you return this. So instead of writing all this, if you lambda functions are like for quick functions, right? Like the way you write it is you say lambda, like lambda is the name of your function. You take x colon and you do what it returns. So what that does is basically, so this value, whatever value you pass x in here, you're going to take that x, multiply it, and return it. So I think I've written a small code in here in that mini project thing. So what I'm doing here is I'm saying lambda id and return id plus 1. So whenever you take id, it'll return you id plus 1, and id value will always be like id plus 1, and yeah, so it takes this thing. But I think Deepika, the reason why you were not seeing it incrementing is you have to probably do this. So
yeah, I just realized it. Yeah.
And then you actually, I think last time when I showed this, I purposefully put another variable to show local functions. That's why I wasn't using. Now it's taking id whatever value, and it's taking id plus 1, and it's storing an id. So that's why it will now increment the thing. So if you just do that change, it will start working.
Yeah, thanks.
So no problem. So that's the use of lambda. So even in lambda, functions can be used for multiple arguments. Let's say if you want to add two things, you will say arg of 1 and arg of 2 colon return me this thing. So these are like quick functions which are very readable. Like for adding something and this thing, you don't need to like wait for like 2-3 variable. I mean, you don't need to write another function to do that. So you basically take that and you add it. So yeah, so those are basically lambda functions. File handling operations, they are like a file can be opened in like basically 3 modes. You can open it in read mode, append mode, and write mode. So once you store a file in your employee this thing, you will actually, if you want to read it, you will actually read. Append is basically going to add to your this thing. So let's say you already have a file and you want to write new data, append the data, you open it in append mode. But when you open in write mode, it will always override whatever is there. So just be careful that whenever you are opening a file in write mode, it's going to overwrite the data. So let's now go through the mini project, like the assignment work. Is that it, or yeah?
So can we quickly see one example of file handling like that?
Yeah. So let's open. I have sent this thing, but let's open this thing. So first, okay, yeah, this is basically pretty much what the assignment was all about. So in the assignment, I wanted to use all the concepts which we did. One is dictionary, lists, functions, and file handling and exception handling, and write this whole code. So what I'm doing here is I created a function called, again, try and except is pretty simple, right? You can use try and except like just to cover your code every single time. If I don't know what exception is there, I'll just say exception as e, and I'll print out whatever that exception value, whatever that exception says. So what we do here is we actually take a file name, and then we open the file in read mode. And then once we open the file, it will return the file handle object here. And then this particular object has a function called read lines. So the way you read all the lines from the file is say file.read lines. So that will give you all the lines in this thing. So now you see the difference. This is one thing which I've opened with read lines, but the other thing I said read with yield. So now now this is a perfect example. You will probably understand like difference between yield and not the same. Let's say this file has like a lot of lines, right? Like terminal. It has like 1 million lines. So when you do read lines, what happens? It will try to read everything and store it temporarily in this. And then each employee you will go inside, and then you try to like split. Like, what I did here is basically for every employee in this line, I'm just splitting it based on so for, okay, this is read, right? First, let us see how we wrote the list. So first thing is because all I said here is like I wanted to add employees, right? So I first created a list here, and then each employee, when I'm adding, I'm actually passing. Look at here, I'm actually using like so I can use keywords here and exactly take those names here, or I can use 2 stars. I think that was one other assignment thing I gave. I can use 2 asterisks and say that it is keyword arguments and refer them as keyword arguments of name, age, ID, and title. But you can do it like this also if you want explicitly the name, age, and this thing. You can still call them with keywords here. So you add the thing, it will basically go and append to this particular list. So every time I am adding an employee, I'm actually appending it to this. Once I finish adding the employees, I say write to file. Here I'm creating a file and I'm passing this particular list because this list is now populated with all the employees, right? So when I say write to file, I'm passing in the name of the text file and then what I need to write in there. So where is write to file function? Here. So firstly, so this is a new file, right? So there is no such file presently there. So I'll open it in write mode. Open the file in write mode, and then now it will create this thing. Now, what do I need to do here? For every employee in this particular list, I'm writing his name plus his age plus his ID plus this thing. So I'm actually having comma here because I need to separate each of their things, right? So whenever I run this, let me run this actually. Is this clear? Like when you're opening in write mode, you'll actually say open in write and then you'll do file. For each employee, I'm going to write his name and everything. I'll close it and then you'll have the employee.txt. If you run this thing, so you see here, it has written this thing. So you can, as soon as I ran, it populated something called as employee.txt. What it is doing is it's written it in as John, comma, his age, his ID, and his designation. So now once I have this particular text file, I can open it in read mode. So I've written it here. Now I say read from file. I did 2 types of read. One is read with yield. Both of them do the same thing, but I just wanted to show you the use of the yield function. So you can either use read with yield or you can actually say file.readlines. Both of them are the same way of reading. So now that I have a file here, it will basically, if I delete this file, if I delete this thing and I call this print function, what will happen?
You get IO exception.
Yeah, so that's why this exception handling is there. That's right. So you get an input output exception because there is no file there. So that's why the first thing is you need to write the file. And especially in this case, I could have created explicit exception called IO exception and printed it. But since it's like in generic terms also, it's fine. You can just create the exception and the string will say no input file by the name employee.txt exists. And then, so basically for every line in the file, I split it. And once I split it, the split will return me a list of, an array list of, an array list. And then I print out the first index and the second index because I know that the first index is the name and the second index is the age. So that is pretty much what like this file handling was there. But if you want to see the whole project is like here. So I create the name, I create a global variable called ID. I didn't want the users to populate ID. And I think there's one place I wanted you guys to. So here in this particular function in file handling, so you see that I'm actually passing using, so keywords can be passed. So even though this doesn't have 2 asterisks, you can still pass by the name, age, and ID. But if you want to pass more things, here the restriction is you only can pass these 4 things. But if I want to pass more things, what I'll do is I'll create this function like this. What I'll do is I will say, copy this. I will say, instead of all this, I will say, what should I have here? Anyone? So how do we take in keyword arguments?
Double star.
Yes. So you say double star and you can give any name. Say args. Just to make it clear, I'll say keyword args. And then I can actually go here and say keyword args of name equals name, keyword args of age equals this thing. Sorry, I'm sorry. This is basically the key. Key should be the same. This is a dictionary, right? It is this thing. I'll say here that keyword args of whatever name you passed. So is this clear? Is it a quick? I just want to do a quick recap.
Shai, last thing I couldn't get it, like this one. So you're saying like you're using keywords name for only one particular column, right? I mean, first argument. I mean, first.
Yes. So the
so
reason is okay. Okay, let me go back to the previous example. So if you have the function like this, right? So if you have the function like this, where you have name, age, and everything, what do you have here? So name actually contains the name of the employee name, right?
Correct.
So I'm creating, this is my key and my value is name.
Okay.
It is stored in this. But when I wrote it like this, when I wrote it with keyword args, saying like this, # keyword args, so it doesn't know what name is because I'm not passing in the name. So, but ideally I don't need I need the value of the name. So this keyword argument, this is the key, but this is the value, right? And how do you access the value in case of keyword? You'll actually have to refer it with like just as we did in dictionaries, right? How do you access the value? You say whatever is your array, right? You actually open these parentheses and then say you give the key value there. So that now this one will give you the value of whatever the name is, because I already put name here. This is my key. I need the value.
So rest of the values automatically get populated, like age and ID and.
No. I have to still. I mean, I didn't complete it. I have to give this again.
Okay.
Because it doesn't know what. If you see here, it is having the red thing under age and title.
Right.
It doesn't, because in previous one I know what age, name, and ID is. In this case, I don't know what they are. Right. I only have keyword args. So what I'll do is I will go and like give this. Even in this, I mean, I have to go and give everything, like for ID and for everything, I have to say keyword args of this. So this is a quick thing of how you can use keyword args to create your function. But if you don't want to use, because you know that it's always going to be this, you can very well, use it like this. So that is the main thing. So is that clear with what we have done? I mean, I just want, because I thought it should be like, I mean, I didn't want to like rush to the next class, but I thought you'll get some time to go play around with the assignment and you will have understanding. But if you have any doubts in what you have done, I hope that this recap should clear everything, right? So I'll go ahead. Any questions until now? All right, I'm not hearing any questions, so I'll go ahead. So I hope this particular recap, you are clear about what the assignment did, how we incorporated file handling, how we incorporated like exception handling and data structures and stuff. So basically, yeah. So basically, most of the time we don't need to write these functions ourselves. Like similar to like C# or Java, Python also has packages. What is a package? Basically consists of a list of functions or utilities which can be reused. Like they just bundle a bunch of related functions and put it, like NumPy, so there are 4 packages which we'll be using, especially for data operation and visualization. These are the 4 standard packages which we will use for in data science. It's NumPy, Pandas, Matplotlib, and Seaborn. So Matplotlib and Seaborn is mainly used for visualization. NumPy and Panda is used for data processing. But before that, we have to first, let's create another project. So there are 2 ways to install packages. So all these packages reside in Python server, like, the website we went to, www.python.org. So there's a central repository where all these published packages reside. So there are two ways to install packages. One, if you are, again, since I'm a fan of like the command line, this thing, let's say if you are actually using command line. So if you remember, we created virtual environment last time. I think we did it in Python. I created an environment called test environment. So we created a virtual environment. So don't worry if you're not using this also, but if you're still using this, I just want to cover. First thing we need to go, and what do we need to do? We need to activate this, right? So we go to sorry. Right. Test environment. So first thing we did here is basically last time we created this virtual environment, and the way we actually go and activate is by calling the activate command. So cd test these scripts. So when we activate it, this environment gets active. So the two ways you basically can install a particular package is called pip install. If you're using command line, pip is basically the Python installer program. I think that's the full form, but it's called pip. So you can pip install, like for example, I'm saying we have these 4 packages, right? NumPy and NumPy, pandas, matplotlib, and seaborn. So let's install, like if you want to install like NumPy, you just need to mention the name NumPy. So it'll automatically go and install this. So it'll go. I already installed it earlier, but it'll go and install NumPy in this particular environment. But you don't need to worry, because for you, PyCharm will install it automatically. So let's create another project. You can create it called like session 2. So file. Let's create one more project. So the way we do that is we go to like project, or you can say file. So file, new project. You can give, let's say I already created session 2, but you can give the name session. Let me create something called session 3. So as you can see here, when you expand, you will see that all the virtual environment, everything is created for you automatically. So I create something called as session 2 right now. Don't create session 3. I'm just creating it because I already have session 2. So when you hit create, it'll ask you whether you want to open it in a new window or current window. Please hit current window and say add to the current open projects. If you don't do this, it'll open it in another window, and every single time you have to keep seeing. You have to open like 2-3 projects and stuff. So just click on open in the current window and say add to current open window. And when you click OK, it'll see it's saying creating virtual environment. So by behind the scenes, what it is doing is it's doing Python -m VNV your virtual environment. So behind the scenes, it's doing that. So I think everyone should do this, because we are actually we'll be dealing with NumPy, pandas, and stuff today. So once you create that, you will have something. It must have created it here. So you'll have your session 2 project here. In session 2, so basically, how do you add, before we write these things, right? You need to first install the package. Like even in Java or this thing, you need to add references and stuff, right? So for every project, again, mind you, if you install the package in one particular project, it won't be accessible in another project, because all the projects will have their own virtual environments. That's the whole concept of virtual environments. That's what we learned in first class. Python works on virtual environments. So when you're creating this project, its property is to refer only one particular virtual environment. If that particular virtual environment is corrupted, then only this project will be affected. You can also point other projects to the same virtual environment if you want, but it's generally not considered safe, because if one virtual environment goes, all the projects will become affected by it. So once you create a particular project, like let's say in session 3, I'll do it in the new project. So I created session 3, but you will create session 2. So you'll go here, you select this project. The way you install the package is say file, settings. So in settings, you will have, you see something called as, you'll have your project 1 here. Click on it. Once you click on it, you'll have project interpreter. Click on project interpreter. When you click on project interpreter, that means this is the Python interpreter. Here you will see all your projects. Session 1, session 2, my first project, I created something called as linear algebra also. But in your case, you should see session 1 and session 2. So in the project interpreter, you click on session 2 for you. I'll create session 3 because I already installed this thing. But see, these are already by default installed. Pip and stuff is installed for you. So here you go and you'll hit the plus sign. When you hit the plus sign, these are all the bunch of packages which are available in the Python repository. Now you will go and say NumPy. So NumPy, so we'll install 4 of these because in session 2, we'll be doing data visualization also. So when you hit NumPy, it'll say install package. Click on it. It'll install it automatically. So you do, in the behind scene, what it's doing, it's doing a pip install NumPy, pip install Seaborn, pip install Matplotlib and everything. But this is how you graphically do it. So if you're really enthusiastic, you can actually go activate that particular environment which this particular PyCharm is using, and you can install it yourself also. But why do all that when PyCharm can do it for you? So it says package NumPy successfully installed. So please install 4 packages. NumPy is one. Pandas is the second one. Install pandas.
Sai, just 1 second.
Yeah.
So we have to go to settings. Sorry, file and settings.
Yeah. Let me let this finish. I'll show it again. So you have to go. So you click on your project, right? And then you go to file. I think it's just doing. Pandas takes a little bit more time. Yeah. Let me just finish this installation. I'll close and open it again.
Okay.
But generally, file, when you click, there'll be a thing called settings. So you click on settings. The settings will open your project. You'll only see whatever project is active right now. In the project, when you drop down, there'll be something called as interpreter, because that's the Python interpreter. So everything you write in Python, the Python interpreter is the one which converts that into machine level bits, right? Because in the first class, we learned that Python is an interpretable language. So the interpreter you have to configure that interpreter for every project of yours. So you go, okay, it's done. So let me do it again. Close this. So you have this, right? So you go file, settings.
I don't have this in my.
Oh, do you see file?
Yeah, I see file, and then there are import settings and export settings.
Yeah, above import settings, export settings, you should have settings and settings for new projects.
It is preferences for new projects. I'm not.
Oh, you're not having settings at all?
No, I don't have it. Mine is Mac, so I don't know if it's.
PyCharm for Mac? Okay. Is everyone else clear on how to do this? So why don't you guys install these 4 packages?
Can you just show it one more time, please?
Yeah, sure. Yeah. So Deepika, what I'll do is I'll ask you to share your screen, and then we'll see what is happening.
Okay.
Okay.
So Sai, in my case, I'm unable to see, once I go to settings, I'm unable to see my session 2 project.
Yeah, you won't see that. You have to click the project interpreter. So you go file, settings.
Yeah.
So you click on, so you'll only see project, because that is the project which is active so far. So you can expand this.
Okay.
And then you have to click on project interpreter.
Once
you hit project interpreter, you will see different projects. You will see, because there's an interpreter for every project, which is selling for project 1, use this virtual environment. For project 2, use this virtual environment and stuff like that. Over here, your session 2, I mean, in my case, session 3, here you will see like, oh, what are the packages installed and stuff like that. So once you go to this page, you go to plus and install these four things. So we did NumPy, I did pandas, you do Seaborn.
So I need to install package by package, right?
Yeah, package by package. So let me see if you can select multiple. No, package by package. So you see Seaborn, and then install Matplotlib. Let me open that so that you know the spellings. So these are the four main packages which we use. It's not math, it's Matplotlib. So these are the four packages. Like, why don't you guys install any questions on how to install this? Is everyone else able to install?
Yeah.
It's NumPy 1.15.2, right?
No, you'll just say NumPy.
Yeah.
So it'll pick up. So the Python. So when you do NumPy, it'll only say NumPy. Yeah, it'll pick up the latest one, whichever is there. So you see that the package is used for array processing of numbers, records, and objects. It'll tell you what. So it's numbers. Anything with numbers in Python is called NumPy.
Okay. So it's NumPy, Panda, and what else?
NumPy, Panda, Seaborn, and Matplotlib.
Okay.
Seaborn and Matplotlib are mainly visualization packages, but NumPy and Pandas are for processing, data processing. So these are the four main packages you have to install for any data processing in using Python. Okay, Deepika, can you actually share your screen?
I actually got to the settings part.
Oh, you got there? Okay.
But yeah, I'm still not able to.
So after settings, what you will do is,
I came to the project.
Okay, so you should see Python interpreter there. So file, then you go to say. You can also do Control-Alt-S to open the settings directly. You come to project, you click this drop down thing. I'm not sure if it's the same in Mac, but you click this drop down.
Yeah. I came to the interpreter part and I selected the particular project, the new project.
Yeah, session 2.
Yeah.
And then you should see a plus sign here.
Yeah, I don't see a plus sign here.
Do you see like packages and everything?
Yeah, I see pip and setup tools.
Yeah, but you should actually see a plus sign here to add a new package. So install. It says alt insert is a new alt insert. Maybe it's a shortcut. So generally in this thing we have a plus sign. So when you hit plus sign, it will open up a new window which says available packages. And all these four are the standard packages which are available.
Not getting anything.
Just share your screen, we'll see what you.
Yeah. It says, you're already sharing the screen.
Okay, I'll stop my screen share and. Stop share. So I'll stop mine.
Okay.
So you can share yours.
So I'm here now.
Oh, you don't see a plus sign. Here, there is plus here down. Go down.
Yeah, bottom
down,
left.
Bottom down.
Sorry.
Yeah, it's just a
yeah, I can.
Yeah, just NumPy.
Yes.
Yeah. All right, you can stop sharing.
Yeah, thanks.
Yeah, no problem. Install package down.
Yeah.
So if you don't want to install, I showed you how to do pip install and all, right? Like generally, the thing is, right, like most people, like if you go to conferences and stuff, they generally like to do command line only. So they'll open Python interpreter, they'll create a virtual environment, they'll do pip install, everything from the command line. So they'll create a virtual environment and then they'll say, okay, when you create a project, they'll say here in the interpreter, right? When you're creating a new project, you see that the virtual, they'll say, hey, don't use this, use this particular virtual environment. So even you can go change virtual environments later on also.
So it's just matplotlib, right?
Mat, M-A-T, matplot.
Yeah. Okay.
Matplotlib, Seaborn, Pandas, and NumPy. So these are the 4 packages which we'll be using. Someone mentioned that they want to learn Jupyter. I don't know, I don't remember, but last time when I was on the call, someone texted or sent me on a chat message. Do you guys want to do a quick example in Jupyter, like to see how Jupyter works? Or are you like happy with PyCharm? Because I'll skip this if we'll be using PyCharm mostly. Anyway, while you're installing and stuff, I'll just show you this thing. Like, firstly, Jupyter is again another package. So in this case, remember here I actually have, I think I have installed. I think I already have Jupyter in here. So basically you create a virtual environment and then you basically install Jupyter. Also pip install. So, and then how you launch Jupyter is by saying Jupyter Notebook and say notebook. So the reason why people use Jupyter is it's basically hosted on a local server. So it's like a screen which you can, so it's on the browser. You don't need an editor. You don't need anything. So it'll basically open everything, and it'll open, and whatever you save in Jupyter, it'll be saved as a Python notebook. It'll have an extension saying IPYNB. So you can actually save it as a this thing. Here, like you can just generally write the code. So because I've installed, let me actually, I'll talk about this. I'll just show you what like the thing with Jupyter. In Jupyter, what happens is you can create these Python notebooks and send it to people. And since it's on the browser, you can actually share your server link and other people can edit it and everything, do things automatically. So let me write a small code in Jupyter. Like even in Python, the way we import packages in PyCharm is say import numpy as np. That means that this is an alias for this, because if it has a big name, right, you can't refer that every single time. So the way we import packages in Python is by saying import whatever your package is, and you say as whatever alias you want to give it as. So similarly, so there are sub packages. A package can contain functions, a package can contain sub packages. So there are like multiple things in a package. So like for example, in matplotlib, there is a sub package called pyplot. So you can actually access matplotlib.pyplot, and then you can give whatever name you want. So let me show you a small graphing function in Jupyter. We'll do that today in PyCharm as well. But the advantage of Jupyter is you can see everything. You can see everything inline. So if I do this, and let's say if I run, see, you see the sine graph here. So you can basically change any. So you can just give this Python notebook to someone. They'll just run, and if they want a bigger graph, they'll say, oh, I'll go from 1 to 100 and then run it again. So now it's from 1 to 1. Anyway, I'll talk of these functions later on, but is everything clear? You see like how Jupyter is, you can see everything inline. You can do a lot of it, like, especially if you're going into academia and most data science people, instead of using PyCharm, they use Jupyter, because Jupyter is one, you can easily share these notebooks. Two, you don't need much installations because you already basically create your virtual environment, you install everything, and you can come and edit it, right? Like if they make, so this is on localhost, but if I create a server which can host like a lot of Python notebooks, you can just directly go there and type. You don't need to install all this PyCharm and everything, and you can see the results directly. Like here I'm showing a plot of a sine graph. Like you can change it immediately and say, okay, run. So let's go sine. Maybe you can. Anyway, any questions on Jupyter? Like I thought I'll just give an introduction to like how to do Jupyter, but we'll be using PyCharm mostly, but feel free to use Jupyter notebooks also. It's the same code. Only thing with Jupyter is you have to have one additional statement called inline. So whatever plots you have, you should say inline. If you don't use inline, the plots won't appear here. They will say, oh, we can't plot it in here. So this is the one additional thing if you're using Jupyter notebooks, you should have. But more other than that, it should basically be pretty straightforward. So anyway, this is Jupyter stuff. Like how many of you heard about Jupyter? Like in data science, I think anyone who's doing a career in data science will. Hello? Anyone who heard about Jupyter or
No.
didn't hear about Jupyter?
I just heard, sorry, but I have never used.
Okay, so basically, and the reason I want to introduce it, like in the future, right? Whenever people say, "Oh, we have it on Jupyter Notebook," it's basically like a different replacement for PyCharm. So the thing is, just as I showed you how you can graph everything and this thing, so you will basically see that. Yeah, you can basically see all the plots in line and stuff like that. But that's okay. So let us continue with some basic. So we've installed this thing, right? So create a new project, create a new file here. Just say numpy basics or something. When you say new Python file, and name it as numpy basics. So numpy basics. First thing what we will do in this is basically we will see how to import a package. We'll say import numpy as np. So you can say import this and then you can give it as, and give whatever name you want. You can give np, nb. The thing is, it'll create an alias for this thing. And then we will see now the functions in numpy. Numpy is mainly used for arrays. Let me do a quick. So let us go to the case study. I'll talk about this case study later on. Let me go to OpenV2. So did everyone finish installation?
Yeah.
Okay. So basically now let's look at so numpy is the first basic package of Python. So we saw how to import a package. So basically numpy is a core library in Python, mainly used for arrays and matrices. The reason we didn't want to use arrays, there's no arrays in Python, is because there are a lot of optimizations and everything which the numpy package does. And universally, anyone who uses arrays and matrices in Python use numpy. So like I said, like let's look at example like using a sine wave with numpy arrays. So numpy can be used for creating like a lot of this thing. So it's used for creating a lot of arrays. It can be used for creating sine waves, cos waves, and like and most of the plotting inputs are given by numpy. So we just saw how in PyCharm how we have created a small sine wave, right? Actually, let's do this. Let's so since you have imported numpy, okay, it's fine. Import this also, matplotlib.pyplot, and you can give it your own name. So this is how you import. Write this. Don't write it in Jupyter. Write it in PyCharm in your file. So you say numpy as np, and then you say matplotlib.pyplot. Pyplot is nothing but Python plot. So Python plot, and then as is an alias. So you can use whatever name you want. So there are a lot of functions in NumPy. Like for example, you can create arrays. So there is a function called arange. It's not arrange. Now np.arange. What this function does is it gives you the start and the end index and the interval between that. So for example, this is 0 to 100 with an interval of 0.01. So that's like a lot of points. So I can give it, if I give it with an interval of 2, then it will give me like 0 to 100 with 2. So this will, so X will have a list 0, 2, 4, 6, 8, 10, so on up to 100. So this is one function in NumPy, which, so the way we call the function is you use this alias dot and whatever that function is there. So X is basically 0 to 100 with a range of 2. And then so once you have this X, you want to find Y, which is the cosine value of this particular X, right? So this is the input. Input is 0 to 100. And so just type these 4 things right now. I mean, just for you to get a feel of like how you can start plotting in NumPy. No need to give this thing because this is only for Jupyter. So you don't need to give matplotlib inline. But in PyCharm, you just give numpy as np, matplotlib.pyplot as plt, and then you give your range from 0 to 100, and then give 2, and then find the cosine value of it in y. So what does y contain now? So x is basically 0. Actually, we can even do this. You can give print x, and you can give print y, just for you to understand like what is happening. So you see that the arange function, how it works, right? 0, 2, 4, so on up to, again, this is not inclusive of the last index. np dot cosine of, you can pass the whole x into this thing. So cosine of 0, like I think people who have done recently trigonometry will know. Cosine of 0 is 1. So you see that it's a cosine wave. So the values of y are the cosine values of x. And then we want to plot the y values. So we have actually imported matplotlib, right, as plt. So plt.plot is basically going to plot y.
So what is that? What is that 2? I mean, the range, right?
Yeah,
so
the range is basically, so arange function, it's arange. It takes start and end up to this index, or like 0 to 100, and then it takes a step. The step is a difference of 2. So if I give it like a step 0.1, so this will be like a lot of values, 0.1, 0.2, 0.3, 0.4 up to 1, 1.1, 1.2. So if I run this, you see like a lot of values. So the way you create all these arrays is like using NumPy now. NumPy has all these things. Plot is still the same because it's more granular. So we are using now matplotlib and NumPy together. So using NumPy, we are creating a range of x values, and then we are using other functions in NumPy to create the cosine value in y, and then we are plotting them on this thing. So when you run it in PyCharm, you will actually see it as another window which will open. Should I run it in PyCharm? Actually, let me run it. So this is the basics of plotting. Now, let me.
I think when I put import numpy as np, it just turns gray.
Because you're not using np anywhere yet. So once you say np.arrange, then it will start because you're not using NP again, right? So unless you use it, it's graying out because it says you're imported this, but you've not used the NP functionality. So once you type np.arrange, then it'll show up.
Okay.
So just quickly, so once you run this, so basically, if you have observed, right, this is a scripting language. So right now I'm actually writing everything as a script. So this particular thing will execute, and afterwards this will also execute. So just don't worry about what is executing later, but you will just see, when I run this, you will see a graph. What Jupyter showed inline, you will see like this. You will see it outside. We'll say figure 1. So we'll learn about plotting. How do you change axes? How do you like make the graph more pretty and stuff like that also.
It says error code like no module name NumPy.
So you didn't install NumPy then?
So
did you add it to session 2?
Okay.
Are you writing? So either your file is not in session 2 project, or wherever your file is there, you should have NumPy there. A quick way to check is basically you can go click on again file, settings, and then project interpreter session 2. You should see NumPy here. That means that your NumPy is installed for your project. But then if that is there, and then you're not finding it, that means your file is not in session 2. Maybe you've created a file somewhere else in session 1, and session 1 doesn't have NumPy.
No, I have created in session 2 only.
So it's still not. It's still saying NP is not found.
Yeah. So you said I need to add that after installing. I need to do anything else?
No. It should be okay. Can you do this? Can you actually go and check if NumPy is there in your project? So how you check it is again file settings.
Yeah, file settings, and then your
project interpreter, and then click on session 2. Do you see NumPy in this list here?
1 second. I don't see session 2 at all.
You should hit project interpreter.
Yeah. Project interpreter. 1 second. Yeah, session 2. Okay. What all I installed actually got installed in
session 1.
Yeah.
So you need to install in session 2. So you need to click on it. That's why. So you need to click on. So what you can do is you can write the same thing in session 1 also. It's okay. I just wanted to segregate between sessions because first session doesn't use any packages, right? So that's why I thought I'll just put it in the.
Okay, for today
after the session you can create it later. For today, create another file in session 1 only. But I guess everyone should be able to plot this thing, right?
Even after I added a range, it still shows gray.
Don't worry about it. Like write the program and run it. Make sure you have the right spellings. NUMPY. Sometimes if you don't have the right spellings, it won't. Meher, are you able to run it?
So till where should I go to print Y or keep going down?
What do you mean?
Should I just type this whole thing?
Oh, no. Just till here. This is basically.
Okay.
So you just need to plot Y. So the way you plot it is, so you have actually named this whole package as PLT, right? So PLT.plot. Plot is a function of this package. So you say PLT.plot and you give Y.
I'm getting same error actually this time again.
What error? Actually, so just share your screen. I'll stop my screen share. So please share your screen. Okay, now right click and say run. No. Oh, you can run it like that also. Where is this file? So you created something called numpy1, okay?
numpy1.
Yeah, that's fine.
And, yeah.
So can you go to project settings? I just want to see if project settings, project interpreter.
Session 2 have nothing.
My first project, you have numpy installed, okay. Just let's resolve whatever error your functions file is there. I think shouldn't be the case, but your functions is showing red, right? What is there?
I removed some. I was rewriting something.
Okay, that's fine. Go to numpy1 again, because I think there's something. You see, your my first project 1 is basically also red, so I'm not sure why it is red. I think maybe it's because of functions. So go to numpy1 and then right click and say run numpy1. So this is cannot import namespace template. Can you go up?
Did I give any?
No, it is fine. It is. No, it's not even running.
It's
some
not
other error.
arrange, it's arrange.
No, go up here. It should say the error. So can you know that's fine, but go up here in this console. So it is saying numpy1, import this thing as numpy, import this as data. It will tell you, if you go down, it will tell you where exactly the error is. HM unit test. Port logging. I don't find this template. Okay. Can you run it again? Right click run. I'm kind of thinking there's something wrong with your first project. Let's quickly, can you install it in session 2 and copy this code in the basic? So just go to file, interpreter session 2, and just add numpy and matplotlib here. Yeah. Install package. And then matplotlib. I think it should run after that. After that, you in numpy basic.py is there, right? Just copy that code there and run. I think there's something wrong with the, because your project is saying red, right? I think it's, I'm not sure why it is saying this thing, but it'll work now.
No, yeah, I mean, it started showing red in last 15 minutes because I was playing around.
Yeah, maybe it is still compiling from like, yeah, that's why let's just start cleanly with this thing. You can stop sharing and I'll.
Yeah.
My thing's having issues too.
What's it saying?
It says file line 1 in module import as. Should I just share my screen?
Yeah.
Yeah. Okay. Oh, okay. Screen. You see it?
Yes. So ELT.show. Okay. Do you have what's it showing? Line 1 module. Compare versions. Module attribute has no version. Oh. And you installed the package correctly?
Where's the settings? Yeah, I checked that too. It says numpy panda.
Pandas, yeah, that's
matplotlib, yeah.
Like when you hover over the NP and stuff, what's it saying? Like
it says like
It's not getting your, but NumPy should actually at least, can you comment out PLT? Like just comment out PLT for now. No, not that one. You have it there, the last two PLT. So it is as PLT, right? That's fine.
Yeah, my laptop just hung.
Oh, okay.
Yeah. Yeah, like nothing's happening. Okay, let's see. Yeah, it just stopped.
Okay, just restart it and then see if that.
All right, sure.
I mean, restart PyCharm and see. Okay. Till then, I'll continue. Can you stop sharing your screen?
Yeah.
So, I mean, these are some minor errors only. I don't think you should try something like really simple with the thing. But I think other people like you guys have finished it, right? Like Deepika, did you get it? Shekhar, Deepika.
Yeah,
I'm
I
good,
got
Sai.
Okay.
I got it.
Meher, are you able to run it? I can't hear him. Okay.
Sorry, even after installing, same error is coming for me.
The same error.
Yeah.
Can you just close your PyCharm and open it again? Sometimes there's a caching issue with PyCharm, so just turn off the.
Yeah.
Just shut it down and restart. Sometimes that'll refresh the cache. I think that should generally fix. Sometimes, so that's what happens, right? When some virtual environments get corrupted.
Mm.
So hold that. I mean, we will look into like if it's not running later. Let's just do some basic NumPy operations. So basically, we've seen how to add packages and stuff like that. So NumPy mainly, as you've seen how you call like sign function in this thing, you can actually call numpy.array. So numpy.arrays are one of the main functionalities of NumPy. So you can do NumPy. So the way you create a array is by saying numpy.array, and you can initialize whatever array you want in it. Like for example, A equals numpy.array of this thing, and now you will have an array of elements. It has the same functionality like how we have did it for strings and list, right? So you can have the same indexing and slice operations for it. Like 2 to 4 means index 2 and 3. 4 is exclusive. Like for example, in this case, before that, right? Like generally shape of a matrix, and so basically a matrix is again like a series of arrays, right? So everyone knows what a matrix is. Like matrix is basically, you can have rows and columns in a matrix. It's basically like a series of arrays. So in general, when you say shape of an array, that shows how many rows and how many columns. Like for example, if you like if I create an array which is like this, the shape of this is simply 4. Like you won't have, because there are no additional rows in this. But if I actually have two things, which is 1 2 3 comma 4 5 6, that means there are two rows. One row is this, other row is this, but there are 3 columns, 1 2 and 3. The shape is 2 comma 3. So is that clear? What is the shape of a matrix? A shape of an array. Shape of the array is basically the number of rows and columns in particular array. Then there's something called as a rank of an array. Rank is the number of dimensions. So what do you mean by dimensions, right? So you have 1 2 3 4. So basically just one dimension. Like these are all values from one dimension. But whereas if you actually create an array which is like 1 2 and 3 and 4 5 and 6, it has rank 2. That means there are 2 dimensions to it. First dimension is basically this row, and then second dimension is basically this. I mean, these are just the terminologies. We won't be using it much, but it's better to know what the rank of the array is and the shape of the array is. So let's do a small example with the array, right? So did everyone, like, did you guys resolve it? Did restart fix it, or are you still having issues?
No, it's still the same problem.
Still same issue with me too. And but then this time I removed few programs from project one, so my rates are gone.
Okay, then try running it from project one again.
Same error in both.
That's strange. It's still saying that some environment is
or is it compulsory that I need to import?
You need to import NumPy, but why don't you like create a new project? Like I just want to see if like right click, create a new project, install NumPy and Matplotlib in that thing, just in case. Like, did you try this virtual environment activate and everything? What I was talking about for Jupyter?
No, I didn't do any.
Okay. Then NumPy should actually should work. For others, it's working, right?
For me, it's not still.
Yeah, but
yeah, it's working for me.
Okay, it's working for you guys, right? Okay, for now, just follow my this thing. Maybe at the end of the class we can see, because then we'll probably take like a minute more and try this thing. But I will be showing the live code here as well, so you can actually follow what I'm saying here. Rest of it, like after the class, then we can just sync up and see. Okay. Okay. So basically, the way we create and for those who are actually able to run it, you can write the code just to start playing with it. Like the way we create an array is called np.array, and you create basically this thing. This is rank 1 because there's only one dimension to this. So you can actually see that there are different functions for it. Like you can print the type of it. It'll tell you that it is a numpy.nd array. So that means it's an n-dimensional array. So you can print the shape. Shape basically is just 3, right? There's no column, so it'll just print 3. But if you create like two arrays in one, like this is one array, 1, 2, 3, 4, 5, 6. This is of rank 2. You can actually print out. You can even say rank of it. It'll print out the rank. And shape is basically going to be 2 by 3 because 1, 2, 3 these are columns, and then 4, 5, 6 is the shape. So technically, your the array which you're creating here is like this: 1, 2, 3, and then 4, 5, 6. So this is what you have created, but it is all in one array. It's an n-dimensional array. So this is like so number of rows is how much? 2 rows. Number of columns is 1, 2, 3. So 2, 3 is your shape. And then you have, and then you can print. So the way you print it is again going to be like row and column. So 0th row, 0th column, it will print 1. 0th row, first column will print 2. First row, 0th column, it will print 4, because this is what you have created. So this is row 0, row 1, column 0, column 1, column 2. So that's how you print out an array. And then you have dot zeros. Zeros will actually create a so every time when you're giving x and y coordinates, this is the rows and this is the number of columns. So when you say np.zeros, it'll create like 0, 0, 0, 0. np.ones, it'll create 1. Everything will be 1. np.full, I mean, we won't be using this. I just want to introduce like different functions. I'll give some work for as assignment, but then just giving you all the functions which NP has. So if you want to create rows and columns, everything having the same element, you will say np.full of 2, 2, and then 7. So it'll print out this particular thing. So this is like how we actually create arrays. There's an identity matrix. Identity matrix is basically 1 0 0 1. So that is basically like, if you like in mathematics, we used to have identity matrix, right? And if you want to create like a random numbers, you will say np.random.random, because you need 2 randoms, one for the row, one for the column. So it'll print out like random arrays and stuff. So this is the first thing, but we'll go to. So this is the indexing operation. Is indexing clear, right? I mean, when you want to index something, it's the same as how we have done with strings. 2, 4 will give you from 2 up to 4. If you have colon, if you don't have anything, it will basically print up to the end. If you have nothing before it till 2, it will print from start to that particular number. If you have colon, it will print out everything. Colon and -1, it will print out the reverse order. And then you can actually have sublists also. So you can say 2 to 4 and assign 2 to 4, you assign these 2 values, and you can actually assign these 2 values. So that is basically the sublists in this thing. So if you actually want to access each individual arrays, individual elements, like because we created like 2 by 2, right? So you can say A of 0, 0. This is the first element, like similar to this thing here. So we've created 1, 2, 3, 4, 5, 6. I'm saying B of 0, 0. This is 0th row and 0th column. So it is 1. 0, 1, 0th row, first column. 1, 0 is first row and 0th column. So this is basically 1, 2, and 4. So that's how you can index different arrays. I'll just stop here because we just wanted to introduce what arrays are and how we access arrays in NumPy. Any questions so far? Anything you want me to repeat, or is everything clear so far, like how we access arrays in NumPy? Are you guys following me on NumPy, or do you want me to repeat any of this thing?
It's clear.
Yeah, it's clear.
Okay.
Sir.
Yeah.
Okay. So at this point, like I'll just take. I want to introduce our first case study, because all these array operations we'll be doing on the case study. So I've actually sent you guys a CSV file. Please open that CSV file. So it actually says Indian liver patients. I think it is session 2. So you'll have a CSV file called Indian liver patients. Everyone see this file? I sent it last class, not this class.
Yeah, we see it.
So basically, I'll just talk a little bit about how the data generally looks for data processing, right? So if you see, 1 second. So this data actually has columns, right? So it has, so this is, each column is one particular feature of this data. So generally when you look at this, it says age, gender, total bilirubin count, alkaline count, total protein count, albumin. So these are all different blood metrics of the blood. Like once you get a blood sample, these are different metrics. So, but then this last column is very important. Last column, it says whether the patient actually has this thing, cancer, or he doesn't have cancer. Looking at this particular thing. So this is what, remember when I first told you what supervised learning and unsupervised learning is, right? So when I said when you have labeled data, we generally use supervised learning. So what that means is, for this particular page, every row is basically belongs to one particular observation. So this is for one patient, right? And every column is a feature. So basically now every row is a new patient. So if I extract now every column, right, like age, gender, bilirubin, alkaline phosphate, total protein, all these are features of that particular observation. But ultimately, whether this person has like a liver cancer or not is told by the label. So everything which has the label 1 is normal. Everything which has the label 2 is a person with liver cancer. So this is what I mean by we use supervised learning when we have this data. So sometimes we don't have this column, so this is our training data set. So in the training data set, we need to have we need to have an observation. And for each observation, we need to have features. And what are the features we have is basically age, gender, total bilirubin count, and all these things. These are features of this observation. So for each feature, we have a label. This label tells whether the person has or does not have the disease. So this is the data set which we have. So using this data set, now you will understand why we are learning these NumPy arrays and matrices and stuff, because we are going to put all these into those arrays and we are going to do some operations on it. But is the data set clear as to like what the data set is? It contains the age and it has like male and female gender. It has different different levels, different features of every blood count and everything. So this is the data set which we'll be using for data visualization initially. So most of the columns which we have in this data set are given here. So this is actually taken from UCI ML repository. This is a standard, this is not fabricated, it is actually original data. So what we will do here is, these are Indian liver patients. The context is, patients with liver disease have been continuously increasing. So this data will help us, we'll write an algorithm in the end, which will, using some data as training, we will test some the other data and see if we have predicted it correctly or not. So this is actually taken from Andhra Pradesh. It has 441 male records and 142 female records. So this is our data set. But I think before understanding this,
quickly, I'm unable to find the file, the dataset file. Either you can quickly resend it again, or
do everyone else have it?
Yeah, I have it.
I have it too.
This is Raghav, right?
Yeah.
I'll just send this. So this particular thing as like the Indian liver patients system. So we'll, for the next, this session and the next, we'll be using this data set for visualizing and everything. But is the data clear, what the data contains and what label for a data is? The first thing for anything is we have observations. In this case, each patient is an observation. But what do we do with this observation, right? An observation basically is a combination of features. Now, features means that every person has some or the other characters, like they have their blood samples, right? So each of them, their age, their basically gender, their blood sample ratios, each of this is a feature of that observation. Ultimately, we have a label which tells whether this particular observation belongs to a class which has the disease or it belongs to a class which does not have the disease. So every machine learning data is going to be of the same format. But then the question number one, looking at this data, can you tell me which columns are most useful in segregating the patients with disease and without disease? Just by looking at it.
Age.
Data set.
Sorry?
Isn't it the data set 1 and 2?
No. What do you mean by data set? No, exactly. So data set is the label. Yeah. But which of these features is contributing to this label? Like data set is the ultimate truth. Like these are the observations. But looking at this features, which of these are relevant for me to use? So I've given you this data. Now the first question is, what do you use all these features? Like some of them, like blood report might contain additional things like cholesterol level and stuff. Do you use cholesterol level also to predict liver disease? So that is the first question you need to ask. First question for any machine learning problem is feature engineering. In feature engineering, basically we have to understand which of these features do we use to classify people into these two sets. So it's really difficult to look at it like this and say, right, let me ask the problem in a different manner. Let me run this thing. You will write this code later on, but I just want to show you like why we are doing this. So now tell me, now this is a graph of total bilirubin. I just took two features, total bilirubin and alkaline phosphate. X's are the features of people who have disease, and these dots are the ones which do without the disease. Looking at this graph, can you tell me anything about like the feature as such?
People with like higher bilirubin contents usually have the disease.
Exactly. So if you look at the bilirubin count, everyone who has a higher bilirubin count has the disease, and everyone who has like even higher alkaline phosphate count also has a disease. So people who don't have the disease are here. So they have like very minimal bilirubin and very minimal alkaline phosphate. So these kind of visualizations are generally very helpful in understanding the data. So that means that if I actually just take the alkaline phosphate and bilirubin and I actually put a box here, right? If I actually say that anything within this box, so this is what training data will tell us. What training data tells us is, looking at this thing, how do I come up with some boundary or some condition which will help me predict, like, so, okay, before that, right? So we have a lot of features like this. All this is making sense because we have this label. But you only use this particular thing when you train the machine algorithm. So once a machine learning algorithm is trained, then you don't have this data set, because that's the whole problem, right? The problem is you need to have an algorithm. When a new patient comes, it should be able to predict whether he has a disease or not. And what will help us to get to this thing is basically this training data set. So when I look at this thing, when I look at this graph here, it is telling me something like how the machine will get to it. Those are different algorithms. But it is telling me that anyone who has a disease anyone who has a bilirubin content from 0 to, let's say, 5 and 2 to, let's say, 600 does not have the disease. Anyone who has above it has the disease. So the machine, we will show how we train the machine, but the machine will learn this data. It will create a box here. It will say like, I'll create a box like this. So now once this data is gone, now let us get a particular, let's get the test data. The test data is not labeled, right? Because the test data that's where we are testing it. So once we get the test data, it will put the test data. It sees whether the test data is in this box or not. If it is not in this box, it will say that person will have disease. If it is inside the box, it will say it doesn't have the disease. Is that clear? Like,
I have a question.
Yeah.
On the graph. So the graph kind of shows there are also people with diseases in that area, right?
Yes. So this is basically a gray area. So that's where you have to, that's where the machine algorithms, there are different machine algorithms. So I'm giving you one machine learned this box, right? I'm just saying, okay, let me share this thing. Okay, so what I'm saying is, like, now we have a graph like this. So the concentration of the dots of people without the disease is here. With the disease is somewhere here, right? Like this. So I'm saying like one machine, and there are some here also. So one machine will learn this boundary. It will say this. So this particular thing is still the error of the machine. So no machine learning algorithm is 100% accurate. So one machine will say, okay, I learned these two lines. Now, when someone new comes, I will see whether his blood sample lies here or here. If it lies here, I will say that if it lies here, I'll say he doesn't have a disease. If it lies outside, I'll say that he has a disease. But then there are a lot of things here. So is this particular machine learning algorithm the best? No, because anything on the boundary it's not sure. So we will see techniques of how we can actually make the machine learn better. Like instead of having linear lines, can we do a polynomial fit, which is like this, which can actually draw a non-linear boundary around this data to actually learn that anything inside this data is basically having a disease, and anything outside the data is not having the disease. Is that clear? This is just the basic of it. But then the first thing I want to introduce is, firstly, what is the data, how do we pick the data? And then what each observation is. Each observation will have different features. Feature 1, feature 2, feature 3. It might have a lot of features, feature n, and ultimately it'll have a label. Label is either has the disease or doesn't have the disease. So whenever we have these labels, we'll use supervised learning. And in these features, not all of them will be useful for us. Only some of them will be useful. So how do we know which features are useful is basically what we are going to learn through matrices. So I have a lecture on matrices, but I think I'll cover it next time. Or do you guys want to continue now, or should I cover it next time? Are you guys tired, or do you want me to cover? Is it okay if I continue?
For me, slow is always better. I don't know about others.
Okay, so, but then we can stop here for today and then we'll continue. But I want to introduce to you how these visualizations are. Is everyone clear about what a data set is and what observations are and what features are?
Yeah.
So basically, when you have a data set, we have different observations. Each observation has different features. And for each of them, you have a label which tells you whether this person has a disease or not. So looking at these, what we will do is we will train the machine with, generally they say test data and train data, right? So there's test data and then there's train data. Now, what is the difference between test data and train data? Train data is the data which we will take to train our algorithm. So we will train. So in this particular case, we'll take this data and we'll make the machine learn these boundaries and stuff by saying that it has the label or not. Generally, test data does not have label. No label. The reason why we don't provide this label is once the machine learns these boundaries, we will use this test data for it to evaluate whether it's performing correctly or not. So how does this evaluation work? This evaluation works because we'll do a little bit of cheating here. The test data, we will know the labels. So generally what people do is when you have this data, right? So they use 50% for test training and 50% for testing. So we have so many samples, right? So what they'll do is they will train it with let's say 320. They'll train it with 320 features and they'll use the rest for testing. But the testing, we won't provide the machine the label. We'll see what the machine will tell us. But since we have the label, we can evaluate how accurate a machine is. Is that clear? Let me repeat that again. So, okay, let's say, okay, forget about a machine. Let's say a kid learned, you gave a kid, again, an apple and an orange, right? So you give the kid different images of apples and different images of orange, and you tell the kid this is apple, this is apple, this is apple, this is orange, this is orange, this is orange. And now the training period is done. How do you evaluate if the kid has actually learned it properly or not? So you took for 5 days, you told the kid, okay, this is an apple, this is an orange, this is apple, this is orange. how will you evaluate if the kid learned difference between apple or oranges?
You test like you take a test.
So what will the test contain?
You show an apple and an orange and tell it to differentiate between it.
Yes. So you know what is orange, you know what is apple, right?
Yeah.
But you will wait for what the kid's response is. So in general, in data, in data science, when you have all these labeled data, you test it with, like, let's say 80% of the data. For the other 20%, you don't tell. So this is the test data. You don't tell the machine what the label is. You let the machine predict the label. But you still have the labels with you. Like, you still need to know what apples and oranges are. So in this 20%, let the machine predict 1 or 2. And then we'll see how many match. Like, the machine predicts 1, 2, 1, 2. And we'll have some results 1, 2, 2, 2, 1. So we will see how many match. So that is the accuracy of an algorithm. So so how do we differentiate between different machine learning algorithms? Is higher the accuracy, higher is the. Is this clear? This is like the most fundamental. We'll repeat this again and again. Once you go through next classes, you will understand this. But once you have the data, you will train it with like 80% of the data. And while training, you will tell what the label is to the machine. So you let the machine figure out how it will come up with some algorithm to figure out the boundaries. But once it figures it out, the rest of the data, you know the labels, but you won't tell the machine. You will say, hey, machine, you tell me what the results are. And once the machine tells you what the results are, then you will compare it with the actual label. And you will see how many matched. So basically, the accuracy is the percentage of which are correct by the total number of this thing. So that is how the whole end-to-end testing and evaluation of a machine learning algorithm works. Is this clear? I can repeat it again if it is not clear.
It's clear.
It's clear. It's clear. But it's like if 80% is this, then do the 20%.
Yes. So it depends on how we divide the data. So using the 80%, we will tell the machine, hey, this has this, it doesn't have this, it does have this, and we'll let the machine figure out. So what the machine will do is it'll first draw, like, I mean, this is not exactly how it does, but it'll first draw one line randomly. And then you'll tell it, oh, this is basically, these are the ones who have the disease. Then be like, oh, sorry, let me draw it here. Then you'll say, no, these are also having disease. Then it'll say, oh, let me draw it here. Slowly, it'll converge to a line where it'll see that, oh, there's a lot of differentiation between this side and this side. Then it'll start drawing vertical lines. And then you'll tell it, no, this label will tell it, no, you're doing wrong. So ultimately, it'll converge like having these two vertical lines. So when you have these two vertical, now the machine says, okay, I learned this. With this 80% of the data, I can draw these two lines. Now give me new data. So now what happens? Now you actually, what did the machine learn? It learned that this line and this line, anything in this section does not have disease. Anything outside this section, they have disease. But now the training is done. Now the other 20% of the data, we know the labels, but we will give the machine. Now when the machine will plot that particular feature, it will find the feature here. So machine will say, hey, this one does not have disease because it's outside my boundary. But then when something comes here, it'll say, hey, sorry, other way around, right? This one has disease because it's outside the boundary. This one doesn't have the disease. So technically, the machine will learn these boundaries. And then in this 20%, we will know basically what the machine has predicted and what the labels are. So this is actual labels. And this is machine labels. So we'll compare it with the actual label and see how accurately the machine learned. So how it comes up with these boundaries, they are all machine learning algorithms. So the machine learning algorithms will help you. We will see that later on once we discuss machine learning algorithms. But is this clear? This is like the basics of machine learning. Like, what is test data? What is training data? Why do we need labels? And when do we give the labels? When we do not give the labels? How do we determine accuracy of a machine?
Yeah, it's clear.
Okay.
Yeah.
Because this is like the most fundamental thing in in machine learning. So how do you read the data set? So firstly, data set, there is an observation. An observation consists of a row. Each observation has features. Like as I told you in the first class also, you are showing the image of an apple to a kid. But then in the kid's brain, he extracts features. Like in this case, we extracted the features and we gave it to you. But in most of the cases, you don't know what features to extract also. So in the case of a kid, he will extract features. First thing he'll extract is color, shape, taste, weight. All these things are the kid's brain will automatically extract when you show him an apple. So ultimately, it's not the apple, but these features are what the kid registers. So it's similarly to a machine. You give it an observation, you won't know what it has to make out, but you have to give it features. The features here are age, gender, different blood sample counts and everything. So these are the features which the machine learns. Ultimately, the label is basically will tell you whether this person has a disease or does not have a disease. So every machine learning algorithm, now this is the fundamental part. What you feed to the machine is fundamental. If you give the machine like rubbish data, it will learn rubbish. So it won't be accurate. So the first thing which we will learn is, given this rubbish data, how do we get data which makes sense? For that, the maths will help us. We need to, that's why we will learn about this, and it will start off with linear algebra and stuff, but we'll learn about correlation, covariance, and see like what are the things, like how does, can you, I think you guys can't see my screen, right? I've been showing the screen forever. So this is basically the math part. So I have a whole equation based thing. Like the maths will tell us like which are the features, how do we take these features, how do we formulate these matrices, how do we actually so like we will learn on like which features to extract and which not to extract. So we'll start with the basic maths operations right now, but later on we'll go into like eigenvalues and eigenvectors and stuff like that. So it'll be more interesting to learn, but at this point I'll stop right here. We'll continue more on Sunday. I can still continue if you guys want, but if you feel like you'll start afresh on Sunday, like right now I'm stopping at a stage where the problem is, given features, not all features are useful. How do we know which features do we need to extract? Is that good, or like do you guys want me to continue? If everyone is okay for me to continue, I'll continue.
Yeah, sure, you can continue.
Okay, so anyone wants me to stop?
Yes, if
Can you please continue?
Okay, I heard like I'm sorry, I'm getting mixed this thing. Okay, only people who want me to stop just ask me to stop, I'll stop. If there's no one asking me to stop, I'll continue with like the matrix operations and stuff. So going once. Okay, if everyone wants me to continue, I can continue. We can start with the basics of what matrices are and stuff. So I won't go into like the covariance and everything today, but at least we saw the problem what we are looking at, right? Like in this particular thing, like when I showed you this, it is very difficult to first visualize what happens in this thing. So first step is data visualization. The visualization will tell us like which features to, how the nature of the data is. And second thing, we'll have some mathematical operations which will tell us how do we pick these features, like given like in this set, we have different features. If I feed the machine all these features, then will it learn, or should I feed only some features? If I'm feeding some features, is there a mathematical way I can determine which features should I feed to the machine? So for that, we need to start with the basics of algebra, which is matrices. So initially, I think we have like 20 more minutes. So I'll just continue with I'll just start with the basics of matrices. So again, I mean, I don't want to go into like what linear algebra is, but anything which is of the equation type, which is ax1 plus b. So don't worry if you don't follow the math. The math is only there to explain how the algorithms work. So we won't be going into super in depth in the math, but we'll cover the points which are useful in helping us to determine which features to use and which not to use. So anything which can be represented like this. So if you have like an equation which is ax1 plus bx, a2x2 plus so on up to an xn equals b, this is like a linear algebra equation. But this equation is very powerful. You know why? Because it's like this. So why do I need to study this? So many problems in data science can be formulated with matrices and vectors. So for example, right, like in our case where we have the bilirubin count, we have alkaline phosphate count. This is our, so everyone got this, right? We'll be working on this data set. So if you don't have this data set, let me know. I sent it like not this class, but last class. So now, yes or no, this is the last set is the label, whether the person has the disease or doesn't have the disease. How do we take this data and put it into matrix and vector form? So what we generally do is in every data science problem, we convert this into the last label is a vector, and all these features are put into a matrix. So matrix is nothing but a collection of each individual feature. So we have this feature, right? Feature 1, feature 2, feature 3. All the features are columns and all the observations are rows. So we make them into 2 features, which is basically the matrix represents all the features and observations, and the vector here represents the label. The label is the last data set. So the fundamental thing which we need to find is, given these 2 things, given this particular row and this particular label, can we come up with a mathematical equation which can explain this? For example, if someone has given me 2 sets of values and told they are related, like if x equals to 50 and y equals to 2, for which value of x will be this? So again, now we are just going into one dimensional thing, right? So let's say we have x's and then we have y. So for x, you have this value. For x2, you have this value. For x3, you have this value. So if we have these things, and if we want to say what is the value of y when x is 2, how do we do it? Like from basic math, like you have x, you have y. X value of 20 produces 64. X value of 25 produces 77. How do you actually
you can find the slope of all these points.
Yes.
And then you can just plug in the numbers which are given so that you get the answer.
Perfect. So that's exactly what we are doing. So let me explain this again. So what we generally do is, when you have different different x values and you have different y values, right? So you have certain x values here, like 5, and this is like 2, this is 3, this is 1.5. So generally we try to formulate an equation which is ax plus b equals y. This is the equation of the line. Exactly, you're saying like we find the slope and intercept. So we try to guess what, so we know what x's are, we know what y's are. We try to guess what these a and b are. Not guess, we have to come at a conclusion. So this is pretty much what the whole algorithm does. So x's here are our observations and y here is our label. So can we come up with an equation which is ax plus some intercept equals y, where y is the label and then x is our observations and features. So remember how in the previous slide I said like we can put all the observations and features into a matrix and the labels into vector. This is 1, 2, 1, 1, 1, 1, and these are observations, right? So these observations I can like those ages and stuff is x1, x2, x3, so on, x11, x21, x, and this one is x12, x22. So this is the matrix capital X. This is our label Y. So can we find these features A and B such that given this particular thing, we will be able to guess this label? So that is the whole mathematical formulation which we'll try to do. Is this thing clear? I please ask any questions at this particular point. So the reason why we are studying these matrices is because of the fact that we need to given, so all we know with this observation is what we have some x's, we have a label. We have some x's, we have a label. But how do I put this into a mathematical problem? The mathematical problem becomes a times x plus b equals y, where y is our label. So once given this particular training set, let's say we come up with a and b, then for every unknown x, we can guess what the y is, right? It's similar to this problem. So let me go back to my screen here. So it's similar to this problem here. So I have an x and I have a y. I have another x, I have a y. So this is our training. In the training, I'm telling you, if I have this x, this is the y. If I have this x, this is the y. If I have this x, this is the y. So I'll tell you learn and tell me what should the value be when x equals 50. So this is exactly the problem which we are seeing here also, right? Because we have different observations and we have the label. So ultimately it becomes like, can we predict this label? When we get a new observation, so this is our training data set. In training data set, we have all these particular features. So we are asking the machine, hey machine, can you learn from this particular data? Like given this observation, you have to give me 1 or 0, 1 or 2, right? Similar to this problem. So when I first asked, how will you guess when you, for the value for 50, you said you'll find out the slope and intercept and then plug in the value of x to find the value, right? It's exactly the same problem, but this is at a larger scale. In this case, x is simply like one dimensional. In our case, x is like multi-dimensional. It has like different rows and different, each observation is the row and each column is a feature. Is this thing clear?
Yeah.
Does anyone have any questions? Because this is like the fundamental thing which we will be learning. So if this is not clear, please ask me now, because later on, it will become more and more difficult if you don't follow this, because we are taking this whole thing. So basically what we want to do is, let me go back here. So for each observation, we will have a1 x1 plus 8. So you see this, right? This is the equation of a line. When you have only one dimension, it simply becomes a1 x1 plus b equals y. But when you have different features, which is basically, so mind you, this each x is a feature. So we want to find a coefficient when multiplied by age, plus some coefficient when multiplied by bilirubin count, plus some coefficient when multiplied by alkaline phosphate level should give us the label. So we need to find out what this A1, A2, A3 are. Once we find out this A1, A2 and up to AN, then once we get a new observation, then we'll just plug in that observation here and then say what the value is. It's similar to this problem here. When we have X and I have Y, we have X and I have Y. Given this is the training data, please find out what this A and B are. So you can actually, I think Satya, you said, right? Like you'll find out the slope and intercept. You will actually find out what A and B are, and then you will say what Y is. So given this data, you will predict what A and B is. That is the training. Once you are trained, once the training is done, that means that A and B is known. Now for a new value of 50, you'll just plug in that value here and you'll predict what Y is. Similarly, for A, in case of the matrix which we have here, During the training, we will get to know what this A1, X1 is, A1, A2, A3 up to AN. And then once you get a new observation here, so once you have learned the data, once you have the new observation here, we'll just plug it into this equation and it will tell you what the label is. Any questions at this point? So coding and everything is secondary, like you can learn coding from anywhere, but this is the fundamental thing which you have to, if you're becoming a data science expert, first thing is, the question is, once you have these features, what are the features which are relevant for us? Like, can I use all my features? If not, how is it that I will determine which features are useful to me? And how do I, once I have the features, how do I come up with a machine learning algorithm which will predict what the label is? And the reason why we are learning these matrices and these arrays and stuff is because this is how the thing is formulated into a mathematical problem. Is this clear?
Yeah.
Anyone having questions? I'll stop for like a minute here to see if any part you don't understand, please ask me right now.
So I still have a question here. Like we see A1 and B1 are unknown quantities, right? A1, yes. A2, A3 are unknown quantities here.
Yes.
X and Y we know, right? From the table, like the table, yes, what you showed.
Yes, X and Y we know. Yes.
Yeah. So so the relationship between the Y, I mean X and Y is what we need to find out.
Exactly.
Right.
So right now we are assuming that in case if it is linear relationship, how do we find that? So it could turn out. So that's why the first concept I'll introduce to you is linear regression. Linear regression, logistic regression. After matrices, we'll talk about linear regression. In this case, so we don't know, like given the data, we are just guessing. Let's say there's a linear relationship between X and Y. Then the equation of the line becomes A1 X1 plus B1 X2 and this thing. Let us see if this has a solution, right? If it does not have a solution, then that means that these both are not related linearly. But let's say if it has a solution, then our machine has learned this model. So using the training data, which is this thing, which is each individual one, using the training data, we are going to calculate what these A1, A2, A3 and AN are. Once the training is done, we know what A1, A2, A3 are. Now a new observation comes. We don't know what this, so I mean, this should basically be Y, or I can just do plus B equals Y. So Y is the label.
Yeah.
So once we actually learn this A1, A2 up to B, so we learn now a new observation, which is test data comes. We don't know what Y is. Machine will give us what Y is because we'll just use the values from the training, plug it into this and then say what Y is. Is this clear?
The way we used to do in stats is we used to take this linear equation and then convert it into a primal. Right?
Yeah, so that is one way. So trust me, we have a lot of math equations which we'll go to it. But this is why we are learning this. But like, why do we need to learn matrices and this thing? Why are we doing even NumPy and everything? It's because of this equation. First is, how do you formulate a mathematical problem from a given data set? This is how we do it. Like, we know the label, we know the data. So we have to find out what this. So this one, since it is a matrix, so A is also a matrix, right? Because you have A1, A2, A3. Sorry, A is basically a linear a vector because you multiply. So you know how matrix multiply. Let's go further, right? Maybe I'm just going ahead of myself, but at least this point is clear.
Yeah.
Yeah. So basically, linear algebra is used for approximations to start with. But see, when I told you this thing, what X and what Y is, we actually they need not be linearly related. Like, you can see that if it is, maybe in this case it is, but you can see that as X increases, Y sometimes increases and sometimes decreases. So maybe a linear equation is not the best fit. But when you are trying to find out the slope and this thing, you will come up with the best solution possible. So it is basically like this. Let me share this again. So let's say in this case, we have X. I'm going to clear this. Let's say in this case, we have X, right? This is X axis, this is Y axis. For some X, Y is increasing. But then after sometimes it is maybe decreasing. And after some time it's maybe increasing. But all I'm saying is I'm trying to see if there's a linear equation which will fit. You can always find an equation which basically is like this. It's the best approximation which we can do. Right? Because in this case, because how can you fit a line which is going like this? So if at all we are fitting a linear, if linear, what is the best fit? So this is the whole problem. So you have this thing, but our best guess right now is we are saying it could be linear, and let me find out this equation. So this equation is what ax plus b equals y. And given these points, we'll say what a is and b is. Now let's say a new point comes. Let's say we are saying, let's say we give you this x. We'll say what is y. Then you will actually go and say this is y. Though it may not be the correct one, it might have some error, but still you're pretty close to it, right? There's still a small delta, but that's still better than predicting something here or here. So is everyone clear with this? So that's what we're trying to achieve with this thing. So when you actually get this matrix X, you multiply it with Y, and then you get this. This is the label. So our whole job is to predict what this matrix A is. And for that, we'll use, there are different ways, like we'll use linear regression. We'll talk about that later on, but you see where I'm going with it, right? So, all right. So then basically, like, why do I need to study this? Because in case of liver patient example, multiple variables such as age, gender, albumin are required to find out if a person has the disease or not. If that cannot be represented, if that can be represented as an equation similar to in slide 2, then it's easier to find out and treat the patients. Everyone agrees? Does anyone have questions? It'll be good to say yes or no, because when I'm talking, it's basically very difficult for me to see if everyone understood or not, but just to make it more interactive, right? Let's say yes or no. Even if it is yes, just say yes, so that I know. Okay.
Yeah.
All right. So then that's the whole problem of how we'll formulate this liver patients example into this thing. I don't want to go into a history of linear algebra and this thing, but generally scalars and vectors, right? So what is a scalar and what is a vector? If you learn basic physics, like vector is something which has a magnitude and a direction. Scalar is something which only has magnitude. Like this is from like high school physics. But what is it relevant to in our case? So scalar in our case represents only one value. Like for example, price of your house, it's only one value. Age is one value, your name. Usually a scalar is represented as a number. So scalars are denoted as X, Y with small letters. Vectors is an order of, like it's an ordered list of scalars. Like in this case, this whole thing is a vector because it is an ordered list of scalar. Each observation is again a vector because it's an ordered list of scalar. So scalars are each individual feature is a scalar, but a group of features is a vector. Is that clear?
Yeah.
Okay. So basically now let us look at another example. So let's say one of the houses. So now if you actually take each individual feature, which is like, for example, in the house, right? Like let's say we have one case study which talks about the market values or like the house prices in New York, right? So how do we represent each particular each house? So as I said, right, even in this example, basically each row is an observation, but each observation consists of a set of features. Now this particular set of features is basically nothing but our vector. So each observation is boiled down to this particular number of features, right? So in this case also, now a house is basically boiled down to what its each individual scalar is. Like for example, the features of the house. So when you're buying the house, right, let me ask you this. What is it like, for example, in this case, a vector consists of properties of the house. I mean, like, let me ask you this, like when you look at a house, like what do you look at? Like what are the properties of a house?
Like size and
number of bedrooms is 1.
Yeah.
Square and the square feet of the house is 1. The lot size is 1. Which year it is built is 1. So what are all these things? Now I'm listing out these things. What are these?
These are the features of the house.
Exactly. So they are the features of the house. So your house is one particular row, and each of these things which you're listing out are the features. So ultimately, your vector of the house is a combination of each features. So now, when I want to represent this particular house in this space, it can be represented as a combination of this vector. Is that right? So firstly, it's 10,000 square feet. It has 5 bedrooms. It has 5 bathrooms. It has 1 yard. It is built in year 2015. So a vector can be considered as a point in an n-dimensional space where n is the length of the vector. In other words, the number of entries of the vector. Is this thing clear? Because now once you have this thing, so all it is saying is now I have like, let me do this again.
So basically it's a 5-dimensional vector.
Exactly. So it's a 5-dimensional vector. So now your house is basically, so your house is now represented as a vector where each of these individual thing is basically a feature. So this is number of bedrooms, number of bathrooms, the square feet, which year it is built, and like, I don't know, like maybe like how many gardens it has, maybe, or how many yards it has. So now each house is represented as this point, as this thing, right? So it's a 5-dimensional vector. So let me ask you this question now. This is like very important to understand. So now let's say if you have a point, right? 2, 3, and I give you a 2-dimensional space. What is this point? This is X, this is Y. Where is this point in 2-dimensional space? So 2, 3 is the point. Tell me where the point is.
Yeah.
So this is 2, this is 3. So this point will be here, right? So now let's imagine there's a 5-dimensional space. This is just 2D. Now imagine there's a 5D. What will this become? In that 5-dimensional space, what will this become? This house with this thing.
It's a point.
It's also a point. So if you actually consider the n-dimensional space where n is the number of features, all these observations will become points. So all these observations, so each point, like think of it as an n-dimensional space. I'm just drawing 2, but each of them, like for example, your house becomes this point here. Another house will become another point here. Another house will become another point here. So depending on the features, wherever those features will put your house, it will become like this. Now, if you want to do an analysis, let's say we want to do an analysis between costly houses and like slightly cheaper houses. Depending on the feature set, the cheaper houses might be somewhere here. So each observation will turn into a point in an n-dimensional feature space where n is your number of features. Is this thing clear? So each of this thing is represented as 5, like, you know, like the one which we did right now, like number of bedrooms, number of this thing. So, and then this could be like the price or something. So the reason I'm drawing this is like, visually we have to understand where each of them lie. Now, if you want to basically write an algorithm which will tell us like, hey, can you differentiate between, if I give you a new feature set, can you tell me if it's a costly house or a cheap house? What this algorithm will do is it'll try to come up with a line or something. So this is basically what the algorithm will figure out. This is the algo. It'll try to come up with a line which will differentiate these two things into two different sets. So now, once the algorithm learns this, all this will go away. Because now the training is done, right? Now the algorithm learned this line. So all this training thing will go away. And now what we'll do is we'll only do testing. Algorithm learn this line. In testing, when the new data comes, if it's on this side, then it'll basically say it's a cheaper house. If it's on this side, it'll say it's a costly house. Is this thing clear? So every observation in an n-dimensional plane where n is the number of features is boiled down to a point. And all the machine learning algorithm does is tries to come up with some separation in that space, which can differentiate between both sets of data. So that is pretty much what the algorithm does. I think at this stage I'll stop. We'll continue with like how we'll extract feature extractions and everything. How do we know which of these features will make more sense in separating the data in the next class? I'll stop at what scalars and vectors are. But is this thing clear? Is the class so far? I think we've spent enough time to understand how to look at data, how to like visualize the data, the problems in the data. What are the features we need to extract? Like, is all the features which they gave relevant or it's not relevant? Is that thing clear?
Yeah.
Okay. Any questions at this point? I think I'll stop here. We're going to cover more on Sundays because we have more time, because I know like it's almost at the end of the night now, but I don't want to like overload. Wednesdays are slightly going to be less content, but Sundays we'll try to get more content in. But the main thing is forget about like programming and everything, but you have to understand this aspect. If you are to explore into data science, first thing anyone will in any company, what they'll do is first thing they'll give you is data. They'll say, hey, this is the data we have. Can you figure out some way to classify them? Like, for example, one data which we had was, one problem which they had in Windows was they gave us the information of all the bugs. Can you say which bug is priority, which bug is not priority? So for that, what you'll do, you'll actually have tons of data, right? You'll say, oh, does this belong to networking? Does this belong to this thing? Who has worked on it? All these are features. But do you actually use all the features to determine the priority? If not, is there a mathematical way or is there an algorithm which will figure out what are the best set of features to use for it? That's what we'll learn in the next class.
Yeah. In this case, probably the impact analysis is something which we'll consider.
Yeah. So impact. How do we mathematically model that impact analysis? Is what we'll learn. So how does change of each feature? Like if I pick now the house is there, right? It's 5 features. Do I use all the 5 features or do I just use 3 features? Do I use 2 features? Which ones, and how do I avoid other features? So that is pretty much what we'll learn the next class.
And is this called feature engineering or is that something else?
This is all feature engineering. Until and unless we go into the fact that unless we learn what the machine will do, it's still feature engineering. So all this comprises of feature engineering comprises of, firstly, sufficient data. Do we have sufficient data? Then we'll go into the bias variance trade-off and we will see overfitting, underfitting and stuff in the next classes. But the feature engineering consists of how do I choose the data to train my model. So that is an 80% of the problem is feature engineering. If you don't have good feature engineering, no matter the best of algorithms you use, it's like no matter how smart the kid is, right? If you teach him nonsense, he'll learn nonsense only. So it's exactly that. So basically, how do you know what to teach the machine? So there are different machines which employ different learning techniques. Like this learning technique which we are going to learn is linear learning technique. But then when you go into neural networks and deep learning and stuff, they learn non-linear ways of communicating, like deep learning and neural networks, RBF kernels and stuff. But then irrespective of how, like, you take the brightest of brains, but if you don't teach them properly, if you don't feed them good data, they can't do anything, right? Like if you still, like if you show like orange and tell the smartest kid that it is apple, he'll still learn it as an apple. He won't, because that's why the training and the feature engineering is the most important thing in machine learning. Unless we, and how do we go about that is basically, is basically what we will learn. Is that clear?
Yeah.
Okay. I hope this class was we'll slowly get into complete machine learning now. So programming is just an initial aspect of it. So we will still use it for for programming and this thing, but the later on of the class, we will just deal with concepts and, like, as someone said, right, what is the most impact analysis? How do we know which feature is most impactful, and what are the algorithms which will tell us? What are the tools which we need to learn for that? So yeah, it'll get more and more interesting as we look at more data. Like for example, next class I was thinking using visualization, I wanted you to figure out which mountain should you go and go ski next weekend. So as you get this data, then you start thinking. The idea is to think like, what should you use in the data? How can you formulate it into a mathematical problem to actually predict or classify the things which we need? Okay, I think I'll stop at this point. It's already 9:15. So any questions?
Yeah, Sai, like, is it possible for you to share the notes right today? Like, I mean, say for example, last week I had some time the next day, and then I got really busy for the next 2 days.
Oh, so you want me to share it? Yeah, okay, I'll share it a little later. I'll just get dinner and then share, because generally I wanted to share it last time, but I got really tired.
Yeah.
I work in the morning, right? So
yeah. So this week has been a bad week. Like I couldn't spend much time on my.
Okay, so I'll share it tonight only. So I'll just get dinner and I'll share it before I go to bed.
Sure.
But I'll share everything. Don't overread and get confused. So we'll go at the pace of the class. I'll share, because I don't want to cut the presentation into half and share it. I'll share the whole presentation. But
sure.
Yeah. All right. Okay. Then if there are no questions, then I'm actually dropping out. I hope this class was at least got you into thinking of like how data engineering and what are the problems, how do you formulate them into, why are we even learning matrices or arrays and stuff.
Yes, it was really opening up, right?
Yeah, it'll get more and more interesting. Like initial classes, that's why even my passion is also not to teach programming languages, it's to teach data science. But it is necessary, right? Like I can't just teach you theory and then you won't be like, from an employment perspective, they need you to write algorithms, code them. So you need to learn programming. So.
All right.
Okay.
Thank you.
All right. Thank you. Okay. I'll see you guys on Sunday.
Thank you.
Thanks, Sai.
Thanks.
Bye-bye.